I'm doing section 5.5, and in our textbook it's on page 249, and it's question 10. So it says, tides are a periodic rise and fall of water in the ocean. A low tide of 4.2 meters in White Rock, BC occurs at 4:30 a.m. The next high tide of 11.8 meters occurs at 11:30 a.m. the same day. So what I've done is just set up a graph that we can plot the information on so it can make more sense. So we're just going to take from the question the information we have so far. So we know that the min is 4.2 meters. We know that the max is 11.8 meters. And then we also know that the times that these occur at are 4:30 and 11:30 a.m. Okay, so on the graph, we're going to put 4.2 as our min, and we're going to put 11.8 as our max. Okay, and then the times, so the min will occur at 4:30, so that is the same as saying 4.5 hours. And the next one will occur at 11:30, which is 11.5 hours. So here is hours on this side, and going up here is meters. Okay, so the next thing that we can do is find the amplitude. So the difference between 11.8 and 4.2 is 7.6 meters. And then if we divide that by 2, we get the amplitude. So first we'll do 11.8 minus 4.2 equals 7.6 meters. So that is the difference here. So to find the amplitude, we can divide that by 2, and then we get the value of 3.8. So 3.8 is our amplitude. So we already have A. This is 3.8. So now let's plot the points that we have. So here is our minimum, and about here is our maximum. So to draw, to connect these lines, you can draw a rough sketch. So it will look about like that, back down, and of course it will continue on, and then the minimum should be moved over a bit, so about like that, and so on. So, here I'll just make this a bit more clear. Okay, so we know that the amplitude is 3.8. So to figure out where the vertical displacement takes place, what we can do is add 3.8, which is the amplitude, to our minimum. So 4.2 plus 3.8, that is equal to exactly 8. Okay, so now we know that here roughly is 8, and that is where our equator is. So just drawing a dashed line that extends. Okay, so we know that that is where our equator is, and we know that this and this are both 3.8, our amplitude. Okay, so now we have found A and D, but we still have to find C, B, and C. So to find the phase shift, the way I did it is I see that the minimum starts here. So if the minimum is here and we follow it up and then back down, this would be a full cos graph, and that would be negative cos. So it starts 4.5 in. So now that we know that the phase shift, which is C, is plus 4.5. Because the graph that you could do this out different ways, but the way I see it is that it goes from here, up, 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 and down, and that would be a negative cos. So now we can find the b. But first, before we find the b, you have to find the period. So the information that we have is we know that this is the minimum, this is the maximum. So this is half a period from here to here, and the difference here is 7. So if 7's a half a period, then we know that 14 is a full period. So our P equals 14, and to obtain B, what you do is 2 pi, because that's a normal standard period, divided by 14 equals, that can simplify to pi over 7. Okay, so now we have all of these, so we can write our equation. So instead of writing y, I'm going to write h, which represents height. So h, here I'll do it in a different color. Oops. Okay, h is equal to negative, because we see this as a negative cosine graph because positive would start up here. Negative our amplitude, 3.8 cos. Now b, so pi over 7. Bracket, and instead of x, I'm going to write t because this is time. T minus, and our c is 4.5, minus 4.5, close the bracket, plus 8, which is our vertical displacement. So this is our equation. Okay, so now with that equation, we can just plug in a number to find. So the second part of the question asks, what is the tide height at 1:15 p.m. that same day? So we already have the equation, and we know that in this case, we're working with a t that is, so it says it's at 1:15 p.m. So to make that into hours, what we can do is, since it's p.m., so we're going to do 12 plus, and 1:15, if you do 0.5 times 60, that equals 2.5, so it's 12 plus 1.25 of an hour, so that equals 13.25 hours. So that is how long it's been so far. So now we're trying to find out what height is, so we can just plug in this number as t and figure out what height is. So we know h equals negative 3.8 cos pi over 7. And now instead of t, we're going to write in this new value, because this value is what we're plugging in for t. So 13.25 minus 4.5 plus 8. Okay, so the difference, so now if you just punch some buttons on your calculator, you'll find out that the height is equal to 10.69 meters. So that is our answer. Okay, thanks for listening.